Today onwards, I'm going to start a paper discussion for science papers in GC ordinary level examination. So as you know, already know, within 3-4 months, you will be facing your O-level examinations. So I thought that it is very rare to find some videos in YouTube about the past paper discussions in English medium, particularly for science and mathematics. So today I'm going to start a discussion, past paper discussion for science. So I will be discussing at least 6 papers from 2018 to 2024. So today the first paper is 2023 science paper. The course code is 34EI. So without any further ado, let's get started. So hope you all have this exam paper. If you do not have the exam paper, you can go to the Google and find for it. And yes, the first question, right, from the MCQ paper, the first question is about production of urea, and it is regarding our excretory system. So question number 1, urea, which is an excretory product, is produced in which organ, right? So this is actually a straightforward question, no arguments need. So remember, urea is excretory product and it is produced within the liver, right? Liver is the organ which produces the urea, right? So you know that from particular organs, particular excretory organs like kidneys, and also from our skin, we release out urea, right? So first one is a straightforward question. You have to know the answer, that is liver, right? So question number 2, right? So this is very familiar one, right? Most of the question papers, past papers, they are giving you to find out some units of particular vectors, right? Vectors or non-vectors, scalar quantities. However, it is a quantity. So they will give you some quantities to find out the units. So there is a very simple way of finding out the units of a particular quantity. But the most importantly, you have to know the equation to calculate that particular quantity. For example, what is the unit of power? So they are mentioning the power here, right? So if you want to calculate, if you want to get the units of power, you should know the equation to calculate the power, right? Otherwise, it would be very difficult to find out. So what is the equation to calculate the power, right? So power is work done per unit time. Unit time in standard international unit, the time is taken from seconds, right? So which means we are going to find out the work done per second, right? That is called the power. So how do you develop an equation to find out the power? So work done per unit time, no? So in the numerator, you should have the total work done, and in the denominator, you should have the time taken, or the total time, right? When you divide the total work done from the total time, you can get the work done per second, or work done per unit time. Usually it's seconds, right? Then, so what is the unit of work, right? So before that, before we apply the units for work done, we have to get the units for work, right? So in the bottom, I have here mentioned the work. So what is the equation to calculate the work? Work is force into the displacement, right? Force into displacement. So in short form, we say W, the work equals to the product of F and S. The F is the force, right? F and S, right? So F is actually measured in newtons, as you know, right? It's Newton, right? Then the displacement is coming, the unit of the displacement is meter, it's a length, right? So in the work, you will have the Newton meter in international unit, not the standard international unit. You know that the Newton is not a standard international unit, but in short form, instead of Newton meters, you can use this joule, right? This is a short form. Joule is a short form for Newton meters, right? Newton meters. So in other hand, you should know that work is equals to the energy, right? Energy. So you know that the units for energy is joule, right? Which means the unit for work is also joules, right? So you can get this joule relationship from several places. Either you can apply that units for work equals force times the displacement, right? And you can get it as joule, or you can remember the units of the energy is joule, and energy equals to the work, which means we also have joule as the units of work, right? So however, from any method, you should be able to take the units of work, right? So let's apply this joule unit, right? Joule unit to the power equation, right? So power equals total work done divided by the time taken. So you have joule here in the numerator. The time is measured from seconds, right? So you know we don't keep these units as fractions. So you have to take this, right? You have to take this denominator to the numerator. So you know that from the mathematics, the denominator will become per or negative, right? So this is the final unit, or joules per seconds, we say joules per second. One extra thing. So as we had a short form for Newton meters, joule, we have another short form for joules per second, that is called W. What is W? That is watt, right? Power is measured by watt. The meaning of the watt means energy per second, right? Joule, work or energy per second. That is W or watt, right? So the answer for the second one is J's minus 1, the fourth answer. Number 3, the formula of an isopropyl alcohol molecule is this. What is the number of atoms in this molecule? So this is very simple stuff, right? Grade 5 stuff. So you know the molecules are made out of atoms. So what you need to do is just count the number of atoms there, right? So this is the particular molecule they have given, right? So let's break down this, right? You have two parts. You have two here, right? So in this right hand side part, you have two hydrogens, right? Two hydrogens there, two hydrogens, one oxygen, altogether 3, one carbon, altogether 4, right? So in the second part, you have how many? Four atoms total, right? So in the left hand side, what they are saying is they have two CH3 groups, So in one CH3 group, you have how many atoms there? You have 4 atoms, 1 carbon and 3 hydrogen, 4 atoms, right? So if you have two CH3 groups, which means 4 times 2 is 8. 4 times 2 is 8. So now in the left hand side, you have 8 atoms. In the right hand side, you have 4 atoms. Altogether, the answer should be 12. Very easy. I hope you understood. Right, now moving on to the question number 4. What is the tissue that transports food produced in the plant leaves through the plant body? So this is from the grade 11 first lesson. That is tissues lesson, right? So we have a division, full division of plant tissues, and you have these complex tissues. There are two types of complex, right, tissues. Two types of complex tissues. The number 1 is the xylem, and number 2 is the phloem, right? So you should know the functions of each of these complex tissues. Xylem usually transport water and minerals, and on the other hand, phloem transport food, right? But the type of food is the sucrose. You should remember that also, right? So they are asking about the food transportation. So direct or straightforward answer here, phloem should be the answer, right? So in another day, they will ask what kind of a food that they transport from the phloem. So you should remember the sucrose is the type of food, right? So you know that from the photosynthesis, they produce glucose. Then when they want to transport this glucose, the glucose will convert into sucrose and will be stored as starch, right? So initially you have glucose from the photosynthesis, and during the transportation it will be sucrose, and when they are storing those food, it will be starch. So you should remember that sequence. Question number 5, when two objects are rubbed together, one of them gets positively charged, transferred to the other, right? So what are the type of subatomic particles they are transferring when we rub two objects together? So this is regarding the static electricity, right? So you have started learning about the static electricity in grade 7, right? So this should be a very simple one. So you know from the basics, right? In the middle, you have the nucleus of the atom, and around that, the electrons are circulating. So in the nucleus, you have both neutrons and protons stick together, and around that you have electrons, right? Remember that nothing in the nucleus cannot go out from the atom, right? They are stuck in the nucleus. Neutrons and protons, they cannot go out, right? Cannot go out, right? So the only subatomic particle that can travel is the electrons, right? So this question is very easy. You don't need to think about protons, neutrons, right? The other two types of subatomic particles. Only the electrons can be transferred from one atom to another, right? So in static electricity, you know that if you suppose you have two types of objects, right? So when we rub these two objects together, right, one will transfer electrons for other, right? So this object, let me mark this as A and B. So A transfers some electrons for B, which means finally the B will get negatively charged due to the electrons. They have excess of electrons now after rubbing. So then they are lacking, the A object is lacking out of electrons, which means they have excess of positive charges, which means the A will be finally positively charged. So this is the theory behind the static electricity. So the answer should be number 5. Moving on to the question number 6. Which of the following includes an acidic oxide or amphoteric oxide, a basic oxide in respective order, right? So they're asking it in respective order. First the acidic, second the amphoteric, right? Then third, they're asking for the basic, right? So this pattern, you should remember this pattern in your textbook in the grade 10 third lesson, as I remember. So in the third lesson, they have given the basicity and the acidity of the oxide formed from the third period, starting from sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine, right? So you should remember there is a way of memorizing this. If you take the third period, sodium, you have magnesium, aluminum, silicon, phosphorus, sulfur, fluorine. You don't need to take argon. Argon is they don't make any kind of compound, right? They are very inert, right? So you do not need to consider the 8 group. So this is the first group, second group, third group, 4, 5, 6, 7, likewise. So when you take, right, so this is how you remember it. So just divide this row into 2, right? So just make 2 lines either side of the aluminium. So in the left hand side, you have these metals, right? Yes, aluminium is also a metal, but listen to me first. Sodium and magnesium, they have very highly metallic nature. And in the right hand side, you have the non-metals, right? So you have metals here, you have non-metals here in the right hand side. So remember, metals usually produce basic oxides, right? They are producing basic oxides, right? And on the other hand, non-metals, they usually produce acidic oxides, right? So you can now take answers for basic oxides here and acidic oxides here. So the thing is, what is amphoteric, right? So I told you at the beginning, just middle the aluminium here, because aluminium is amphoteric. What do you mean by amphoteric? Amphoteric means in aluminium oxide, the oxide of the aluminium, it contains of basic features. It has some basic features, and also it has some acidic features. Both of the features, right? They have the aluminium oxide. It has both features, like basic features and acidic features, right? So that is called the amphoteric nature of the oxide, right? So from the beginning again, metals, they are producing basic oxide. Non-metals, they are producing acidic oxides, right? So in this chart also, you can see the purple color ones are basic ones and the green color ones are acidic ones. In middle, you have aluminium oxide, right? Aluminium oxide is amphoteric. So now you can get the answer. If you look at the first answer, sulfur dioxide, sulfur is non-metal, right? Non-metals are producing acidic oxides, right? So this is acidic. So just look at the sequence. Just look at the sequence. They're asking first, they're asking acidic. Secondly, they're asking amphoteric, and lastly, they're asking the basic one, right? So acidic. The aluminium oxide is amphoteric. That's correct. Silicon dioxide, again, silicon dioxide is acidic, right? Silicon here, it's non-metal, so it's produced acid. So it can't be the answer. You have 2 acidic compounds there. Second one, this is acidic sulfur. Third one, this is amphoteric. Yes, that's correct. Magnesium, look at the magnesium. It's a metal. Metal usually produce basic one, right? So now you have the correct order in the second answer, right? So one thing here, the carbon dioxide is usually it's a non-metal, then which means it produces a basic oxide. Sorry, the acidic oxide, right? My bad, I'm sorry. So carbon dioxide is acidic oxide, right? Now moving on. So answer is number 2, right? Question number 7. In plants, good question. In a plant cell, blank can be called non-living structures. So you don't need this much of information in grade 11 or grade 10 or level level. But I have here included the living components and the non-living components of the cell, right? So plasma membrane, you have to remember cytoplasm, nucleus, mitochondria, chloroplast, ER or the endoplasmic reticulum. You have 2 types, SER and RER, and Golgi apparatus and ribosome. Those are living components. So as per your syllabus, the only non-living component in the cell is cell wall. Apart from, I mean, in higher education, you will got to know these are also non-living, but you don't speak about these components in the grade 10, 11 level, right? So here, the cell wall should be the answer. You can remember it straight away. Others are living components. Moving on to the question number 10. Another morphological feature of a plant bearing the leaves with the venation shown in the diagram is, right? So you have this leaf and it has parallel leaf venations. Look at the arrangement. The leaf venations are parallel to each other, right? So that is why we say this is parallel leaf venations. And you have another type of leaf venations, net-like, or we say reticulate venations, right? So this is actually a comparison of monocot plant and dicot plant, right? I hope you remember what the monocot plant and dicot plant. If you cannot remember, example for monocot plant is coconut, right? It's coconut. Just remember coconut, right? Just imagine a coconut plant, right? And in dicot, you have plants like mango, right? So if you want to get if you want to differentiate between monocot and dicot, just imagine a coconut plant and also a mango plant. So let's start from the seeds. Why monocots? Yes, in the cotyledon, you have only 1 cotyledon in the monocot plant, in the seed. So in the dicot plant, you have 2 cotyledons in the seed, right? Just remember. Then when you talk about the root, what about the root system of the coconut? Do they have a taproot, large taproot coming out from the bottom of the stem? No. In the coconut, you don't have a large taproot, right? It has only a fibrous root system, right? So in the dicot plant, in the middle, you have a very large taproot and the lateral roots are arising from that. So just imagine a root system of mango. Then you don't need to remember about the vascular system in grade 10, but I have here included that. You don't need to remember that. So, however, the leaf venations you should remember, if you have in the coconut plant leaf, you have parallel leaf venations. The lines are the venations are parallel to each other, never intercept. And net-like, which means the reticulate venations in the mango plant leaves or the dicot plant leaves. And lastly, you have this flower, the petal arrangements, the number of petals in the flower. In the monocot, it should be 3 or 3 multiples, like 6, 9, 12, 15, likewise. And in the dicot, it can be 4 or 5 multiples, which means 4, 8, 12, 16, or 5, 10, 15, 20, likewise, right? So now let's look at the answer. They're talking about this kind of plant. So which means here you have parallel venations, which means they're talking about monocot, right? So let's look at the answers. Presence of taproot system? No, it is not. It is not a feature of the monocot, it is a feature of the dicot. Having a branch stem, right? So one thing missed here is the stem, right? The arrangement of the stem, right? So in the monocot, imagine a coconut plant, they are not branched, right? Not branched, the stem is unbranched in the monocot, right? In the dicot, stem is branched. Mango stem, right? Imagine a mango stem, you have branches all the way around, right? So which means in the dicot plant, you have branch stem. So the first thing is also wrong, the second thing also wrong. Having one cotyledon in the seeds, yes, right? So this is parallel venations. Parallel venations are in monocot. Monocot means in the seeds you have one cotyledon, right? So the correct answer should be the third one. Look at the fourth one, bearing tetramerous or pentamerous flowers. Tetramerous or pentamerous flowers means tetra means 4, right? Tetra means 4, penta means 5, right? So yes, it's a feature of dicot plant, right? So 4 cannot be the answer. So the answer should be number 3. Question number 1. So this is actually a false question. Maybe in the marking scheme they have given the answer as all or 3, right? All or 3. So everyone got free mark for this. So let's talk about that. Which of the following statements on electromagnetic waves is false? So you have several features in electromagnetic waves. Let's look at one by one. They transmit energy. Yes, electromagnetic waves or any kind of wave, it will transmit energy. Even in mechanical waves, you have sound waves or water waves. They also transmit energy, right? So this one is correct. Wow. Then the second one, they travel with the speed of 3 times 10 to the power 8 ms minus 1 in vacuum. Yes, that is the speed of the electromagnetic waves in a vacuum, right? When the electromagnetic wave enters into a medium, it decreases the speed. Right? A very, 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 not much, a bit. They will decrease the speed a bit, right? Third one, frequency is less in material medium than in the vacuum. Yes, what about that? The frequency is less in material medium than in a vacuum. So it cannot be, right? So usually, V equals F lambda or mu lambda, you can say. The velocity of the electromagnetic wave is equals to the product of frequency times lambda, right? So remember that the frequency is produced from the source, right? Whatever the electromagnetic source, it will produce the frequency. It's a particular, very specific frequency, and it will not change. Even they enters to another vacuum, another medium from a vacuum or whatever the medium, the frequency will be a constant, right? So frequency will not change, right? So on the other hand, I told you the speed will decrease when the electromagnetic wave enters to a medium, right? It will decrease, and from the same fraction, the lambda will decrease. Not the frequency. Frequency is a constant. So the third one is incorrect. Frequency is less in material medium than in vacuum, right? So this should be the answer. That is why they have given the answer, the more specific answer as the correct answer as the 3, but they have given the all as well, because this third one, we are not going to talk about this decreasement or the constant frequency about this for constant frequency in your level, but this equation. From the equation, your mind should be developed to argue, right? Yes, we know the velocity will decrease, which means the lambda will decrease, but frequency is a constant, right? So remember that. Fourth one, speed is less in the material medium than the vacuum. Yes, I told you several times, speed is very less in the material, not very, sorry, right? It's bit reduced when the electromagnetic wave comes from the vacuum to a medium, right? So the fourth one is correct. However, the answer for the ninth one, the correct answer for the ninth one is third, but they have given the all as the answer. Everyone got 3 marks. 10th one, which of the following statement is true about ionic compounds, right? So they are talking about ionic compounds. Example for ionic compound is sodium chloride. So the ionic compounds are made out of sodium or the positive ion and a negative ion, right? So remember that these are very strong attractions, right? Electrostatic attractions, Coulombic attractions are very strong. So yes, let's look at the answers. They are asking about the true statement. they conduct electricity in solid state, right? So there is a short note to remember. In ionic compounds, you have three forms. So you have solidic ionic compounds. For example, if you take sodium chloride means common salt. In Sinhala, we call it lununa, right? So let's say you have sodium chloride in solid form, some lunu kata or crystal sodium chloride, crystal salt, right? Right now, then on the other hand, when you heat up the solids, right? When you heat up the solids, it will melt, right? It will melt, right? So then you have the sodium chloride liquid. We say we have a fused form. Fused form means you take the solidic form and apply some heat and it will melt down, right? So when you melt down a solid form, you say it's a fused form. Then there is another way of making the liquid out of the solid form, which means you add some water. You add some water to the solidic form, then you will get sodium chloride aqueous, right? A solution aqueous, right? Which means the solidic all these positive and negative ions, cations and anions are dissolved in water. You have both the positive and negative sodium chloride ions and also the water. Then we have this aqueous form as well, right? So you have three forms: solidic forms, fused form, and also the aqueous form. So what is the short note here? The solidic form, they will not conduct electricity, right? Not conduct electricity, right? Electricity. Right. Now, the fused form and the aqueous form, they have these moving ions, right? So they can conduct electricity. They will conduct electricity. Fused form and the aqueous form will conduct electricity, right? So this is the short form. Just take the note down, right? So first one, the solid, they conduct electricity in solid form. That is incorrect. They're asking for the truth statement, right? All dissolve well in water. Let's keep that for a second, right? So boiling points and the melting points take high values. Yes, usually we have only two types of bonds. Now, sodium chloride is an ionic compound, which means it has ionic bonding. And for example, HCl, H2O, carbon dioxide. Remember, we draw Lewis structures for those molecules. We are drawing Lewis structures for covalent compounds. So there are two types of bonds. There are covalent bonds and ionic bonds. Usually we say in ionic bonds, they have high melting and boiling points. That the bondings are very strong, right? Very strong when you compare it with the covalent bonds. So ionic bonding, yes, the boiling points and melting points are very high. They do not conduct electricity in fused form. It's wrong. The fused form and the aqueous form, they conduct electricity. So here the second one, I told you to keep it for a second. So they dissolve in water. Yes, most of the ionic compounds, they tend to dissolve in the water. But there's a word, right? You should be very careful when you have this word all, right? So all dissolve well in water is incorrect, right? So this is not the answer. Boiling points and melting points take high value. Right, so this is the first, this is the end of the first part of this 2023-2024 science paper part 1. I will be meeting you again in the second part of the first paper very shortly. So until that, have a great day.